All right, good morning or afternoon, everyone, and thank you for joining us on D-Link's Introduction to Power over Ethernet Knowledge is Power webinar. I'm Carrie Mertz, Field Marketing Programs Manager for the D-Link's Solution Provider channel, and I have Steve Olin, Director of Product Marketing for Business Networking, here with us today to present. So welcome, Steve.
Thank you, Carrie.
Before getting started with the presentation, I'd like to review a couple of important items. We are recording this webinar and it will be available tomorrow for viewing, and I will include the link in a follow-up email that will be sent tomorrow probably around 12 o'clock Pacific time, so look out for that, and there'll be a link in there for the recorded version if you need it. Or you can feel free to contact us directly after the webinar. Our main phone number will be in the follow-up email as well. All attendees' lines are muted, so if you have a question for Steve, you can enter it any time during the webinar in the Q&A panel, and then we'll be addressing all questions at the end of the webinar. If you are not able to get to all the questions on the webinar, we'll definitely make sure to follow up on any ones that we missed. Also, the last few minutes of the webinar, we'll be doing our drawing where 5 lucky attendees will get an 8-port POE switch, and you must be on the webinar for a chance to win. So we'll call those out, and then we'll contact you after the webinar for shipping and everything else. And with that, I'll hand things over to Steve to get us started. There you go, Steve.
Thank you, Carrie. Again, my name is Steve Olin. I'm with D-Link Product Marketing. Thank you, everybody, for joining. Over the next 45 minutes or so, I'm going to take us through Power over Ethernet. This webinar is intended to be pretty high level, but very comprehensive. So I'm going to cover Power over Ethernet, soup to nuts, but perhaps not take a deep dive into any particular technology. We'll save the really heavy-duty technical stuff for maybe a follow-up webinar. So here's our agenda for today. I've divided the webinar into 3 sections. We'll start by talking about the basics of Power over Ethernet. We'll define some terms and some acronyms, talk about the IEEE standards. We'll talk about powering modes because there's a couple different ways that you can do PoE. And then I've got a small section here to talk about a future standard that's in the works. It's called higher power PoE. Then the second section of the webinar, we'll talk about practical aspects of PoE. As an IT manager, why would I want to deploy PoE? What are the benefits, and what are some applications? So I'll cover that and then go into the third section, which is a little bit more technical. And I want to talk about PoE power budgets. There's sometimes a little bit of mystery around a power budget on a PoE switch. So we'll talk about that. And then the last section will be comparing and contrasting unmanaged PoE switches with smart PoE switches. And I'm going to try to make a compelling argument that just for a few extra dollars, the benefits and the features that come with a smart switch far outweigh those of an unmanaged PoE switch. Okay, so let's get started on the basics here. Definition on Power over Ethernet. This is my definition. PoE is a system that safely transfers both electrical power and data to remote devices. And note here I've underlined the word safely. PoE is done in such a way that there's safety involved. If I were to touch the contacts on the RJ45 connector, I wouldn't get zapped, and we'll talk about that. If I plug a PoE cable into a non-PoE device like my laptop, it's not going to ruin my laptop. So all of this is built into the standard. So PoE is both power and data over a single LAN cable, typically Cat 5e or better. I think one of the standards says Cat 3 is okay, but nowadays everybody's deploying 5e or better in their networks. So let's start with some definitions here. One of the definitions I use throughout this presentation is PSE. And the PSE stands for the Power Sourcing Equipment. It's the device that provides the power in a PoE network. You can have a couple different types of PSEs. There's an Nspan PSE that's located at the end of an Ethernet link segment, and a Midspan PSE that would be located somewhere in the middle of an Ethernet link segment. And I've got an upcoming slide that shows a little bit more detail on PSEs, Nspan versus Midspan. The other acronym to define here is the PD, the powered device. And that's the device at the other end of the cable. He draws the power from the PSE. So we think a lot about IP cameras and wireless access points as 2 very common examples of PD. So in a PoE network, you'll always have a PSE providing the power and a PD who's consuming the power. And a very important point here is that if it's an industry standard, a valid PD, it will present a signature in its hardware to that PSC. That tells the PSC that it's a valid device. Without it, the PSC will not apply the POE power on the cable. It will certainly establish Ethernet link and pass traffic, but it won't put the POE power unless it sees that signature. Here's some examples of Nspan PSCs. These are POE switches. There's a couple 8 ports, there's a 24 port. These are Nspan devices because they generate the Ethernet signal as well as act as a PSC by putting the power on the cable. Here's a couple examples of Midspan PSCs. The two on the top are single port PSCs and Midspans, and yes, even the device on the bottom, although that looks like a POE switch, it's not. That's actually a 24 port Midspan PSC. A Midspan typically has 2 ports, an in and an out. So the in is the Ethernet coming in, and the out is the Ethernet coming out with the POE power also on the cable. A lot of times Midspans are referred to as POE injectors. So this slide better illustrates the differences between an Nspan and a Midspan. Here you're looking at an Nspan. So I've got a 5-port switch. 1 port is POE enabled. I've got my LAN cable plugged into that POE port, and the LAN cable is connected up to 100 meters, and you know that with IEEE 802.3 Ethernet standard, we can go up to 100 meters over the LAN cable, and at the far end is my PD, in this case an IP camera. In this case, the Ethernet switch is acting as the PSC. It's Nspan because it's generating the Ethernet signal, and it's a PSC also putting power on the wire, and that's signified by the dashed red and black line. Now compare that with the example on the bottom. This is showing a Midspan POE injector. So on the left side we have an Ethernet switch, and this is a non-POE Ethernet switch. So he's generating the Ethernet signal, but he's not doing anything beyond that. And he's sending that Ethernet signal all the way, again, 100 meters down the wire to the IP camera on the right side. And somewhere on the middle of this Ethernet span, somewhere mid-span, is our POE injector. And that is the device that's acting as the PSC in this case. Now that PSC, that midspan, can be located in the middle of the Ethernet link. It can be located over on the left. It can be located over on the right. It really doesn't matter. All it's doing is passively passing through the Ethernet signal, and it's injecting power on that cable. So it doesn't influence the 100-meter maximum that I have from the Ethernet switch on the left over to the IP camera on the right. Now, more definitions. I just want to make sure that we understand with an RJ45, with a standard LAN cable, there's 8 wires in that cable. And in the world of 10 base T and 100 base T, or in 10100, 4 of those wires, 2 pairs, are carrying data. So pairs 1, 2, and 3, 6 carry data. And in 10100, the other 2 pairs, 4, 5, 7, 8, they're actually not used. And in gigabit, 1000 base T, all 8 conductors, all 8 wires, all 4 pairs are carrying data. So 1, 2, 3, 6, 4, 5, and 7, 8 carry data. And this is information that we'll use a little bit later here in this discussion. So let me introduce the POE standards. The first POE standard came out in 2003 from the IEEE. Prior to 2003, there were some vendors doing non-standard implementations, but we had issues with interoperability back then. If vendor A had a POE switch and vendor B made an IP camera, there were no guarantees that we had interoperability because there were no standards. So the pre-2003 proprietary implementations are a little bit beyond the scope of today's discussion. There's not a lot of that equipment out there in the industry anymore. For the most part, IT managers are using Ethernet standard POE switches and endpoints and PDs. So 802.3 AF was the first standard that came out in 2003, and it's typically referred to as POE. It was followed up in 2009 by 802.3 AT. Sometimes we just call it AT. A lot of people call that POE Plus because it allowed more power to be carried over the LAN cable, more power than the original AF standard provided. And then there's a new standard in the works now referred to as 802.3 BT, lowercase b, lowercase t. It's currently in development. There's an IEEE task force working on it now. Ratification for BT is targeted somewhere out in the 2017 timeframe. And I've got some slides on that coming up. I just wanted to put all the standards on one page here and introduce them. So let's talk in a little bit more detail about the first POE standard. This is AF, came out as I mentioned in 2003. So with 802.3 AF, it allows for up to 15.4 watts of power to be available at the PSE port. And remember, we're talking about a LAN cable that can be going 100 meters long, and we're going to have voltage drop along those 100 meters. So the way the standard works is it provides up to 15.4 watts at the PSE port, and that ensures that at least 12.95 watts would be available at the PD, whether it's an IP camera or a wireless access point, up to, let's round it up to 13 watts available at the PD, even with voltage drop along that LAN cable. So it does this by using an output voltage somewhere in the range of 44 to 57 volts DC, and it limits the maximum current to 350 milliamps. The AF standard, I believe, says Cat 3 is okay, but certainly my recommendation would be Cat 5 or 5E or Cat 6 or better. And as I mentioned earlier, I think pretty much everybody today is deploying 5E or better in their networks. And another thing to keep in mind here, and we'll need this later in the discussion, with 802.3 AF, it's sending power over 4 of the 8 conductors in the cable. Which 4 we'll talk about, but it's interesting just to keep in the back of our minds here. It's using half of the wires in the cable to actually transmit that power. Now let's look quickly at AT. AT came out in 2009, and it increased the amount of power that's available in a POE system. So with 802.3 AT, it makes available 30 watts, up to 30 watts at the PSE port. And again, with voltage drop at the other end of the cable, it ensures that 25.5 watts of power is available at the PD. It does this by using a DC voltage between 50 and 57 volts. Note that the minimum voltage from the previous standard was raised from 44 to 50 here. That's one of the ways that they attained this higher power rating. And they also raised the maximum current from 350 milliamps to 600 milliamps. The standard says Cat 5 is okay, but certainly Cat 5e or better is recommended. This standard also uses 4 of the 8 wires in the cable. And the nice thing about AT is it's backward compatible with AF. So in other words, a PSE that supports 802.3 AT can certainly power an older AF PD over either Cat 5 or Cat 3 cabling. So I mentioned earlier that there's a detection process. A valid or a POE power source, PSE, is going to go through a sequence to make sure that whatever's connected at the other end of the cable is indeed a valid PD before it actually applies the power. So let's kind of take a walk through that. This is my own depiction in a very, very simplified way on how that detection process works. And this is more looking at AF than it is AT, but again, I wanted to keep this simple. So the first thing that happens here after I cable my switch to my endpoint, in this case an IP camera, is the switch looks for that signature, and he does this by sending a low, very safe probing voltage, and he's looking for basically a 25 k ohm resistor that hopefully he'll find in the PD. And so in our situation here, the PD says, well, you know, I'm not even powered up yet, but I am able to tell you that, yes, I have that 25 k ohm resistor that you're looking for. And so the PSE would say, that's great, then I will consider you a valid PD, an industry standard 802.3 AF PD. Now there's an optional process called classification. Would you like to classify yourself? And in this case, the camera says, yes, I'm a Class 2 PD. And so the PSE understands that, and he says, okay, since you're Class 2, you're telling me you'll never need any more than 7 watts. So I'll limit you to 7 watts maximum. And now I'm going to apply the roughly 50 volts of DC power on the wire, and you can boot up. And after you boot up, then we can establish Ethernet link, and we can start sending data. So again, this is a really simplified view on how that signature detection process works. We'll take a look at another example when I plug in my laptop to a PoE switch. Now, my laptop is not a valid PoE device, and I certainly don't want to blow it up with 50 volts of DC power. So when I plug in a PoE switch to my laptop, same thing. He's looking for that 25 k ohm resistor by sending out a low probing voltage, and my laptop doesn't have that resistor. So he says, sorry, I don't have that. You're not going to find that here. And the PSE is smart enough to say, then I will not consider you a valid PD, and I will never attempt to put that 50 volts of DC power on the LAN cable. However, we can still establish Ethernet link and start communicating and sending Ethernet data. So I hope that gives you a quick idea on how that signature detection process works. I want to shift gears here and talk about what I mentioned earlier, different powering modes. There's two different ways, according to the IEEE standard, that a PSE can provide power to a PD. And they call them alternative A and alternative B. So with alternative A, the PSE applies the PoE power on pins 1, 2, and 3, 6. And with alternative B, it's putting the power on pins 4, 5, and 7, 8. So I've got some semi-technical diagrams here that show how this works. I know this is a little bit technical, but bear with me here. The first one I'll show is in a 10100 network. And remember, in 10100, we have data on 1, 2, and 3, 6, and 4, 5, 7, 8 are not used. So this is 10100 with alternative B. And alternative B puts the power, the PoE power, on the unused pairs. We're called spare pairs, 4, 5, 7, 8. And that's what I'm depicting here. So the solid black pairs are data only, and the red pairs, the two red twisted pairs, are the power. So again, 10100 network, alternative B, data on 1, 2, 3, 6, power only on 4, 5, 7, 8. Pretty basic. Now we'll take a look at 10100, but this is alternative A. This is the other way that the standard allows power to be applied. In this case, data is also still on 1, 2, 3, 6, but we're actually putting the power, the PoE power, on 1, 2, 3, 6 as well. So that's signified by the red and black dashed lines. We've got both Ethernet signaling and the steady 50 volts of DC power on the same conductors at the same time. And it's pretty neat because they don't know about each other, they don't influence each other, they don't impact each other. It's done using a technique called phantom power. Phantom power is a little bit beyond the details of which are a little bit beyond the scope of today's discussion. Just suffice it to say you've got both power and data riding on those conductors, and they don't impact each other. So again, with 10100 alternative A, everything's happening on 1, 2, and 3, 6. 4, 5, 7, 8 are still unused. Now when I shift into gigabit, remember gigabit, all 8 conductors, all 4 pairs carry data. So in this case, with gigabit alternative B, I've got data on 1, 2, 4, 5, 7, 8, 3, 6, and the power, using phantom power, is also on 4, 5, and 7, 8. And then it stands to reason on my last slide here, gigabit alternative A, again, we've got data on all 4 pairs, and in this case, the power is riding using phantom power over 1, 2, and 3, 6. So I know that's a little bit complicated. I added this summary table here just in case for future reference. It's something that you needed to know. This shows what we just reviewed on the previous slides, showing in a 10100 network and in a gigabit network for both alternative A and alternative B, what's on the different wire pairs. Data only, data and power, or power only. So I'm going to take a little pause here and ask a question. Is it better? You're shopping for a PoE switch, and you recognize that some PoE switches use alternative A to put the power on the wire, some use alternative B. Which is better? What's better in your shopping decisions? And I'll give you my answer. My answer is in a PoE switch, it really doesn't matter. A PSE, power sourcing equipment, can support either mode. And that's because the PD, if the PD, your IP camera, your access point, your PD, to be standards compliant, must support both modes. So a PSE and Ethernet switch can put the power on 1, 2, 3, 6, or 4, 5, 7, 8 because the powered device can accept it either way. It can take it on 1236 or it can take it on 4578 if it's a standards compliant PD. Okay, I mentioned earlier there's a new standard in the works, higher power POE. Basically with higher power POE, we're using all 4 pairs to transmit power out to the PD. So when we get to this 4-pair power over Ethernet, alternative A versus alternative B goes away because we're using all the conductors. Today there are others who have proprietary implementations of 4-power power over Ethernet, but again we have the same interoperability concern. A vendor who's got a 4-pair power over Ethernet switch may not be interoperable with a camera vendor who requires that. So the IEEE has stepped in, and as we speak, the IEEE is working on a new standard. They actually formed this new working group back in April of 2013. They're in the task force stage. I believe one of the original objectives that I saw was to be able to deliver at least 49 watts out to a PD, but as I'll show on the upcoming slides here, it looks like they'll be able to do even better than that. The nice thing is they're looking at 10G base T considerations as well. 10G base T is 10 gigabit over 100 meters of LAN cable. So to be able to do PoE and 10G base T is going to be a really nice thing. And of course BT standard will be backwards compatible with AT and AF. So my understanding is draft 1.2 is currently in review with the IEEE task force, and they're targeting ratification in 2017 timeframe. Although somewhere out in 2016, I believe the standard will be solid enough that chip vendors and system vendors like D-Link will start manufacturing product based on the draft standard. So a little bit more on BT, 4-pair power over Ethernet. I didn't mention types 1 and 2 earlier when we talked about 802.3 AF and AT. The new standard will define 2 new types of PSE and PD, type 3 and type 4. Type 3, in all likelihood, achieving 60 watts at the PSE interface, and type 4, somewhere between 90 and 99 watts, I believe, is what they are looking to do in the IEEE standard. There will likely be considerations for how many Ethernet cables can you have in a bundle. Remember, when you're running this kind of power through the LAN cables, they're going to warm up a little bit, and if you have a bundle of cables, you will have some heat considerations. So address that. I'm hearing that for the type 3 PSC, keeping LAN cables in 100 or less per bundle is likely what we'll see, and for the type 4 PSC with 90 to 99 watts, it'll be less than that, and I'm not sure I know what that number is, but we'll stay tuned and we'll stay on top of the standards committee's work, and we'll learn that as it comes about. PoE will continue to fall under low voltage category. Later in this presentation, we'll talk about the benefits of PoE, why an IT manager would want to deploy PoE, but one of those is that he doesn't need to hire an electrician to come in and do AC work because PoE falls under low voltage wiring, so his low voltage guy can do that. And with the new standard, the new BT standard, because they're keeping the voltage under 60 watts and under 60 volts and the power under 100 watts, they are ensuring that it continues to fall in the low voltage category. And with the new BT standard, it will open up new markets for a lot of really neat new POA applications. For example, LED lighting. Think about the lighting in an industrial facility and being able to use LED lighting and being able to power that LED lighting using power over Ethernet. You can do a lot with that. You can control it. You can have a lot of functionality, and I know that some very well-known lighting companies are actually participating in the IEEE standard on the task force, making sure that their voice is heard as well. So again, foreshadowing here as the standard continues to evolve, but I see some pretty neat things coming when BT is ratified. I think this is my last slide on BT, just showing type 1 and type 2, which is AF and AT, and then type 3, type 4, showing that the minimum voltage for type 3 will remain at 50 volts for type 4. I believe the committee is talking about bumping it up to 52 volts, 4-pair capable for type 3 and Type 4 extended power is an additional feature that will be hopefully available with Type 3 and Type 4. There you see the maximum power of 60 watts for Type 3, 90 to 99, I believe, for a Type 4, and then different classifications, which is a way of further segmenting how much power is provided. In classification, I think, is a little bit beyond the scope of today's discussion. We'll save that for the next POE 102. So here, the same diagram I showed before, but with 4-pair power over Ethernet. Pretty basic. We're using all 4 pairs for data, and we're using phantom power on all 4 pairs to provide power out there as well. Okay, so that's kind of the basics of power over Ethernet. I'm going to go into the second section here and talk about the benefits of PoE. As an IT manager, why would I want to deploy power over Ethernet? To me, anyway, it gives you a lot more flexibility. It allows you to install end devices. Think about, again, IP cameras or wireless access points. I can put them in strategic places where otherwise it might be hard to get AC power. In a warehouse, I could put my IP cameras way up in the corners where I don't have access to AC power for my wall warts. For wireless access points, I can put them up above the ceiling tiles in plenum airspaces where there may not be AC power. As long as I can reach it with a LAN cable, I can deploy my end device. And I can also move those devices to, as long as I can move my LAN cable. So I may have deployed an access point, and a few weeks later I realize I've got to move it 20 feet. As long as I can move my LAN cable, I can move that access point. And I don't have to worry about calling an electrician to come in and move an AC power outlet. From a functionality point of view, it allows me to reset my end devices. We talk a lot about IP cameras and the fact that they're not always perfect, and sometimes I have to reboot a camera or an access point. With power over Ethernet, instead of having to get a stepladder and climb up to that camera, I can simply unplug the LAN cable, plug it back in again, and I've just rebooted or repowered that end device. And of course, with PoE, things get a lot simpler. All I have to do is install my LAN cable. I don't have to worry about wall warts anymore, so I've minimized cable clutter. And as I mentioned just on the earlier bullet, I'm saving money because I don't have to hire an electrician. I don't have to worry about permitting. I don't have to have anybody put in power outlets near my end device because everything's happening through the LAN cable. I also see a benefit of safety, especially in outdoor applications. Quite often with outdoor, I want to put a camera or an access point outdoor. There's a lot more safety considerations with AC power, but with PoE, I've negated all of those considerations. So I've got a few slides here now just to go through some PoE applications. You're probably aware of many of these, maybe some you're not, and I'll get you thinking about some ideas. The first one, probably the most common PoE application in the business environment, is with IP phones. I think every office I've had over the last 10 years or so has had a PoE-powered phone in it. Even some video phones now can be powered through PoE. Quite often, IT managers get a little bit nervous about having their voice traffic on the same network as their general data traffic, but there's tools that are available like VLANs, virtual local area networks, that can be used to actually partition the network and keep the voice traffic separate from the general data traffic. So here's just a simple diagram showing a PoE switch connected to some IP phones with a LAN cable, and the LAN cable carrying both voice or data and power. In the security industry, using PoE to power IP cameras, probably the most common application. In that industry, most, if not all, business class IP cameras will support power over Ethernet, even some consumer cameras. And if a consumer camera doesn't, there's other ways around that, and I've got a slide coming up shortly to address that. Same consideration here with VLANs. If an IT manager doesn't want to use or gets nervous about having his surveillance traffic traveling through the same network as his general data traffic, tools like VLANs can be used to partition the network and keep that separate. Here's one, access control. So quite often you've got door controllers or badge readers or card readers that can be POE powered, and there's a lot of benefits here to doing that. If I don't have POE powered door controllers, then I've got to get AC power out near that door, and I need probably pretty expensive AC power backup. In the event of a power failure, I still want to be able to operate that door. That can cost a lot of money. With POE powered door controllers and badge readers and card readers, then all I have to do is run a LAN cable out to that area. And if I'm concerned about power failures, then I just use a UPS on my POE switch. So a fairly low cost UPS on my POE switch in the event of a power failure keeps the POE switch running, which in turn keeps the POE running out to the doors so they continue to operate. And of course, systems like this, these door controllers and card readers, typically can be integrated into other surveillance and smart building systems. So it really makes sense from a POE perspective. Wireless access points, I've mentioned that already. Another very common use of POE today. It allows me to put my access points in strategic locations where they'll be optimized for my wireless networks, and I don't have to worry about whether or not it's within reach of an AC outlet for the wall wart. As long as I can reach it with my LAN cable, then I'm good to go. All of D-Link's business class access points support power over Ethernet, as I suspect most of the other AP vendors do as well. Here's one that I really like, IP clocks. IP clocks they can be either analog clocks like shown here or digital clocks. And they don't need AC power. They don't need batteries. The only input into an IP clock is an RJ45 LAN connection. So this IP clock is getting its power from POE, and it's getting its synchronization, its data from some NTP network time protocol server that's on the network. Or actually, you can synchronize with NTP servers that are out on the internet as well. So this is a really neat application. I think it's great for school systems. We sell a lot, D-Link sells a lot of our switching and wireless and surveillance equipment into school systems. And so they've already got the POE network in place with access points and cameras. They can add IP clocks into that same network as well. And all they need to do is have, as I said, an NTP server so that all those clocks are synchronized. It's a good application. You think about daylight savings that's coming up, I believe, this weekend. With this type of a system, as soon as daylight savings occurs, all of those clocks will advance or go backward in synchronization, and we don't have to have a guy climb up on step ladder and manually change those clocks one at a time. So IP clocks, really neat application for POE. I'm showing here on this slide an Ethernet repeater. Remember that with 802.3 we can go 100 meters over a LAN cable. There are some companies that make these little devices that can be powered by POE, and they can terminate and regenerate that Ethernet signal. In essence, these are little two-port Ethernet switches, and they're powered by POE. The one I'm showing here gets POE plus power from the switch, goes out 100 meters, and then it regenerates that Ethernet signal, and it actually has enough power left over to provide POE out to the end device. So kind of a neat little device to extend Ethernet. You make these, but you can certainly Google it and find some companies that do have these available. Now, let me ask you a question. That little device here, is that a PSE or a PD? And my answer is it's both. It's a PD because it's receiving power from the switch on the left, and that's what operates it. That's what turns it on and operates it, but it's also acting as a PSE because it's propagating or it's extending POE power the rest of the way, the second 100 meters down to that PD, the IP camera. Here's a POE splitter. This is something that we do have here at D-Link. A POE splitter is a device that you would use if you have an end device, an access point or a camera that does not support POE, but you want to take advantage of the POE in your network. So we're showing here a POE switch that's putting POE out on a particular port, going out up to 100 meters, and then it goes into the splitter, and what the splitter does is it breaks out the DC voltage and the Ethernet signal. So you can see there are two cables that come out of that splitter. One of them is solid black, that's the 10100/1000 Ethernet that would go into the camera or the access point. And then there's a barrel connector, a DC cable that comes out, and there's a slide switch on the splitter, and the user can select from 5-volt DC, 9-volt DC, or 12-volt DC, which are probably three of the most common voltages that would be required to operate a wireless access point, or I'm showing here a little bit more of a consumer-grade camera that doesn't support power over Ethernet. But again, with a splitter, I can take advantage of PoE in my network, and I can continue to avoid the need for AC to DC wall wart type adapters that would otherwise be required. A lot of other applications for PoE that we don't have time for. There's intercom and paging and public address systems. Certainly digital signage as we go from the AT to the new BT spec. There'll be more applications for signage and video kiosks. There are a lot of environmental and industrial sensors that you can get today that are PoE powered. And then, as I mentioned earlier, LED lighting is a new application that's coming fast and furious, and I see good things happening there. So in summary here on this section, a lot you can do with PoE, and it really makes it an ideal technology for schools and business buildings, and hospitals and hotels and retail outlets and all sorts for surveillance, wireless, clocks, and telephony. Okay, how are we doing on time? Good. I'm going to go into the last section here just quickly and talk a little bit about PoE power budgets, and then talk about smart PoE switches. PoE power budget is pretty simple, actually. It's the total amount of PoE power available in a PoE switch. And this power can be allocated across all PoE ports as needed. So port 1 maybe is providing 4 watts, port 2 is providing 10 watts, port 3 is providing 12 watts. It doesn't have to be equal. It's whatever that PD needs to operate. And it's cumulative. I add up how much power is being provided on each port. That's how I get to my total budget that's available in the switch. Now, all PoE switches are different when it comes to power budget. Some of them actually have what would be called a full AF or a full AT power budget, meaning full AF, which is 15 watts, meaning concurrently could power 15 watts across all ports concurrently. AT, a full AT switch, would be 30 watts across all ports concurrently. A lot of PoE switches have less than that in their budget. Remember that all applications don't need a full budget. Most IP cameras, for example, I'm running an 8-port switch at home, and I have 8 IP cameras, and each camera is drawing between 2 to 6 watts. So I don't really need a lot of PoE budget in my switch. On the other hand, I do recognize that there are some applications, there are some wireless access points that support the new standard, the AC standard, 802.11ac, and those do need a significant amount of power. And so you'd need a higher, if you've got an 8-port switch and you're powering 8 access points, you may need an 8-port switch with a higher budget. So the message here is to do the math. Understand what your PDs require in terms of power, and you can get that from their data sheets from all IP phones and access points and cameras. On their data sheet will tell how much power they require, add it up, and then you'll know how much budget you need in your switch. And certainly the more budget means a more expensive switch, and there would be additional thermal challenges as well. The more power that a switch is providing, it may have additional fans. Here's some quick examples of some D-Link switches with different PoE budgets to further illustrate. This first switch is an 8-port switch. Its total PoE budget is 78 watts. Now it supports the AT standard, so it can provide up to 30 watts across any port. So I can do 30 watts on port 1, 30 watts on port 2. That leaves me 18 watts to be allocated across the other ports. But if I were level loading the power just on average, and I do the math, 78 divided by 8, roughly about 9.8 or 10 watts this particular switch could provide across its 8 ports. And again, 10 watts for my home network is more than adequate to power my IP cameras. Here's a little bit of a beefier switch, the DES1018MP. This is a 16-port switch, and it has a total POE budget of 246.4 watts. So if I do the math, this is actually 15.4 watts on each port. So here I could indeed support 16 IP cameras or 16 access points all running concurrently and all drawing the full 15.4 watts concurrently. This particular switch here has 8 ports. Its POE budget is 140 watts. The math on this one comes out to be 17.5 watts per port. So again, I'm getting even more on average, more power per port, but I pay for that. I pay for that in terms of cost as well as probably extra fans. And looking at an extreme example, this is one of our managed switches that normally has a 370 watt power budget. If I connect it with an optional a DPS 700, that is an external power supply that in essence is doubling its POE budget to 740 watts. This particular switch now can run 24 devices, all pulling the maximum of 30 watts. So again, keep in mind that PDs only draw as much power as they need. Most are going to require less than the AF standard allocates at 12.95 watts. So as you're shopping for a POE switch, understand what your application is and how much power is needed, and keep in mind there's no reason to go overkill on POE power budget. All right, lastly, let's quickly look at different types of POE switches. Starting at the basic, there's an unmanaged switch, and an unmanaged switch is simply that. It has no management capability. So you plug it in, you cable it up, you turn it on, and it forwards Ethernet frames all day. But there's nothing that's configurable in an unmanaged switch. When we get to managed switches, the entry level is called a smart switch. And a smart switch is typically going to have a management interface using some kind of a browser-based graphical user interface, a very intuitive, easy-to-use interface. And it allows you to configure a limited or an essential set of layer 2 plus switching features. Wrong way. And then at the top of the spectrum here, the fully managed switches can typically either be managed using the graphical user interface or quite often with a command line interface through some kind of an out-of-band console port. And a fully managed switch will have a full suite of layer 2 plus, and sometimes even layer 3 switching functionality. So that's the full landscape. What I'm going to talk about now is really just looking at unmanaged versus smart POE switches. And the argument that I want to make here is that for just a few dollars more, you can get a smart POE switch and get a whole host of features and benefits that come with a smart switch that you don't get with unmanaged, much of which is related to the POE functionality in that switch. So here I'm looking at 2 D-Link switches. Both are 8-port switches. The one on the left is unmanaged, and in fact only the first 4 ports support POE. Typical street price on that, I looked online the other day, was around $99. The switch on the right is a smart switch, so it can be configured using the browser-based graphical user interface. It can be accessed from anywhere as long as you have access into that network. And this particular switch has roughly the same POE budget. In fact, all 8 ports are POE capable, but because it's a smart switch, it gives you that capability, and $28 more online. So for an extra few dollars, you get a lot of extra capabilities. And let's kind of look at those very quickly. Here is an actual screen grab from that switch's user interface. We're at the top level here. You see the navigation tree on the left. And there's a lot of different things that I see. So certainly I can see the information on that switch itself. What's the model number of the switch, what firmware is it running, its MAC address, what IP address have I given it, and of course it needs an IP address so that I can manage it using this browser-based graphical user interface. So a lot of good information in that top portion. Now as we sort of scroll down through the menu tree on the left, there's a lot of different capabilities. We don't have time to go through them all. I'm going to highlight things here like SNMP. So a smart switch will have the ability to send out SNMP traps, which are alerts to the network administrator, letting the administrator know anytime there's a change or disruption to the network, and that's not something you'll get with an unmanaged switch. We talked about VLANs previously, virtual local area network. VLAN allows me to partition my network into 2 or more distinct broadcast domains, and I may want to do that if I want to keep my voice traffic and my data traffic separate. A lot of switches like D-Link switches also support tools like auto surveillance VLAN, which is kind of like a VLAN wizard or a VLAN for dummies. It's a real easy way to have the switch go out there and discover, in the case of auto surveillance VLAN, the switch will discover cameras, IP cameras and NVRs and other components that are attached to the network that should be part of the surveillance VLAN, and it'll automatically assign them to that VLAN. Auto voice VLAN does the same thing with IP telephones. There's a lot of diagnostic tools you get in a smart switch that you don't get in a unmanaged switch, like loop detection, cable diagnostics. But what I really want to focus on here, since this is a POE discussion, is the POE power control you get with a smart POE switch that you don't get with an unmanaged switch. So let's talk about POE power control. What kinds of things can I do through that graphical user interface? Well, I can reboot a PD right through the software from my living room at 3 o'clock in the morning. I don't have to do a truck roll. With an unmanaged switch, I got to send a guy out to the site, and he's got to unplug the LAN cable and plug it back in again. But with a smart switch, as long as I have network access into that switch, I can pull up the user interface, I can pull up the POE part, and I can disable and then re-enable the POE power on any particular port, and I've basically just rebooted that camera or that access point. With the smart switch, I get real-time power statistics. So real-time, I can look and see how much power is being consumed on each port. Remember, I mentioned my home network, I've got 8 cameras, and I can see that the first one is pulling 2 watts and the second one is pulling 6 watts. And I can add it all up. In fact, the switch does it for me. The switch tells me how much power I am consuming, and it compares it with my budget, so it tells me how much power I still have remaining. I can prioritize ports in the event that I'm actually getting close to my budget. I can specify certain ports as being top priority, so if I exceed my power budget, those will not be shut off. Those will continue to receive POE power. I can create POE time profiles, so for each port in that switch, I can give a time schedule, and I can say on port number 7, turn on POE at 8 o'clock in the morning and turn off POE at 5 o'clock at night. And I may do that if I'm powering something like access points at a school, and I only want the wireless network up during school hours, and at night I want the wireless network to come down. And I can specify POE limits. We talked about classification a little bit earlier in the presentation. Not all PDs classify themselves, and there may be reasons why I want to limit how much power my PSE provides on any particular port, and I can do that through this menu. So here we're looking at a screen grab for the POE port settings. This is an 8-port switch, and you can see here in the red boxes, all 8 ports have POE enabled, and the power is on. I can certainly disable the power on any port if I choose to. Here's for me, the most important section is where it's showing me real time how much power each of the 8 ports is actually providing. So port 1 is providing 2 watts, port 2 providing 6 watts, 3.3 watts on port 3. And if I were to go to the next screen, the POE system settings, it would total up that power. It would tell me roughly, I think about 32 watts is being used. This switch has a 78-watt power budget, so it would tell me I still have 46 watts to spare. So that's nice to have. And again, you don't get that in an unmanaged switch. If I wanted to have a time range, turn the POE on and off during a particular time schedule, I would do that here. Here's where I assign priorities to the different ports. Here's where I can actually set the power limiting on any particular port, and it's showing me on any PDs that have classified themselves what their classification is. I can see a couple class 3s and a class 2 PD. And I do all of that configuration from the top portion here, where I can configure either one port at a time or a range of ports together. Okay, so that wraps up. How did we do on time? We're running kind of long here, so pardon me for running fast. But on summary here, what did we talk about? We talked about power over Ethernet. It's an industry standard. To me, the two primary benefits of industry standards are safety and interoperability. We talked about the benefits of POE. It saves money, no need to hire electricians and worry about AC wall outlets. So it really simplifies installations. We spent a little time talking about power budgets and talking about there's different POE switches with different POE budgets for different applications. Do the math. Understand whether you need a heavy-duty POE budget or whether a lighter budget can save you money. And then we looked at the differences between smart POE switches, where you get a lot of added capabilities, a lot of tools. You can turn POE power on and off from far away, and you can't do things like that with unmanaged POE switches. And that's it for the presentation. Should we take a look at the questions?
Yes, we have a lot of questions that came in, so thanks everybody. If you have any additional ones, definitely send them in. If we don't get to them, just as a reminder, we'll definitely follow up with you and make sure we get any questions answered, and I'll let you start at the top.
Okay, Bill asks about POE injectors. Some injectors are called passive. Are there active injectors? When is one or the other needed? I honestly don't know. I can give you my best guess on this. I would call a POE injector passive simply because the Ethernet signal is passing right through. It's not terminating and regenerating that Ethernet signal. So for me, even though it's applying power and it's doing something, it's passively passing the signal through. Now, I did show an example of a little two-port repeater that was being active. It was terminating the Ethernet at 100 meters and then regenerating it and giving you another 100 meters. So in that kind of an application, I would consider that to be more of an active type of device. Does POE, the next question here, does POE impact gigabit transmission speeds? My answer on that is no. POE is a steady or constant DC power on the copper conductors, and Ethernet is ones and zeros, and they're coexisting on that copper, at least when we're using phantom power. They're coexisting, but the way that center tap transformers are used within the devices, these two things, the steady DC power and the Ethernet signaling, they don't know about each other, they don't impact each other, so I'm not aware of any cases where POE power would impact gigabit speeds. What portion of the POE detection is done over power wires and what is done over the data wires? The simulated or the simplified example that I showed for the POE detection, where the PSE was looking for that 25 k ohm resistor, that's done over A, it would be done over 1. If it was alternative B, it would be done over 4, 5, 7, 8. And that's a physical layer detection where it's looking for that signature so it knows it can start applying the DC power. So it could be power wires, could be data wires. It depends if it's alternative A or alternative B. What happens after that is the optional classification process. And I didn't talk a lot about classification. The classification is where the PSE asks for further information from the PD in order to perhaps limit how much power is applied. So classification, I think in AF, is done also at the physical layer looking for additional resistance in the wires. With AT and the new BT standard that's coming out, there's optional classification that can be done actually through software using protocols like LLDP-MED, which is Link Layer Discovery Protocol, I believe. So that's a little bit more sophisticated, and it's happening more and more as we get more and more sophisticated with POE, but that was beyond the scope of today's discussion, talking about Link Layer Discovery Protocol. Is there any problem with video interference with gigabit Ethernet using POE with cameras? None that I'm aware of. Again, POE and the data that are on the wires are completely independent of each other, and they're completely isolated from each other, even though they share the same copper conductors. This is my understanding anyway. Will BT be able to power external IR lights or illuminators for nighttime video? Yes, I believe so. I believe that's one of the, well, certainly we can, AT and AF are powering IR illumination today, So in some of my cameras at home, they're outdoor cameras, they're nighttime cameras, and at night they turn on the IR illuminators within the camera, but I know that there's some external illuminators that require even more power, and I would imagine as we get into 60 watts or 100 watts coming across that PoE connection, then certainly BT will be able to do that. So we'll stay tuned for that. That's another interesting application. Roger asks, are all of these power options DC? Yes. So with 802.3 AF, AT, and BT, it's DC. It's roughly 50 volts. I think the screen grab that I showed was showing from the D-Link PoE switch 53 volts of DC power going out to the PD. Ed asks, do you have any PoE switches that have dual power supplies for fault tolerance of supplying power? Dual power supplies. Most of our switches, especially our PoE switches, just have single power supplies inside. When we get to chassis switching, we have the ability to have slide-in power supplies with dual or even triple redundancy. When we get to some of our 10 gig switches, we have interchangeable power supplies, but in general our rack mountable and our desktop power supplies don't have redundancy built in there. Great info, great idea on IP clocks. So simple that you don't have to think about the battery replacement and the time change. Yeah, I think it's neat with IP clocks. I could talk about that application all day. I remember when I was a kid, every classroom had a slightly different time on the clock. They weren't synchronized, and with IP clocks, it eliminates that. We worked with a couple different clock vendors. I'll mention one called Master Clock. They donated a couple clocks to us that we used at trade shows when we demoed this particular application. I think their website is just masterclock.com, so if it's something that's of interest to you, I would recommend some of their clocks. Really neat. Do all PDs run at the same voltage, i.e. 50 volts, or does the PSC provide different voltages to the PDs? So the industry standard, I think for AF, allowed the PSC to provide anywhere from 44 to 56 volts within that range, and the PD can handle it. With AT, the industry standard said, look, you got to do at least 50 volts in order to keep the power up. And with new BT, I think they're going, at least for the higher wattages, they're going to 52 volts. So let's just say from 50 to 56 volts is the typical range, and all PDs can handle that. But they're not doing things like lower voltages. Like I know there's some proprietary implementations of PoE out there that are using 24 volts. That is not industry standard. To be industry standard, it needs to be basically between 50 and 56 volts.
Let's ask one more, and then we'll wrap up and choose our winners.
Yeah, there's a lot of questions here. We'll do the last one. And which one are you highlighting? Where can we get more information about the new AF standard and LED lighting? I know a couple that sit on the IEEE task force, so I get my information right from them. But I'll tell you, you go to IEEE website, and I just Googled it, IEEE, just Google 802.3 lowercase b, lowercase t. And one of the first Google hits will take you to the task force website. And they have a public area and they have a private area. And you can click on the public area and you can see all of the PowerPoint slides that these guys present as they meet, I think, in their quarterly meetings. And there's a lot of good information there. You can look at the meeting minutes. It's all public information. You can look at the attendee list, and you'll see some of the companies that I mentioned that specify in lighting that are sitting on these committees. So just go to IEEE 802.3 lowercase b, lowercase t, and you can go into their public area and get some pretty neat information. Okay.
All right. Thanks, Steve. All right, we have a few more questions, so we'll follow up with anyone that had questions that we didn't get to. And thank you, everyone, for attending again today. We hope to see you on another webinar. Just as a reminder that we did record this webinar, so there'll be a follow-up email that goes out tomorrow, and there'll be a link in that email where you can access the recorded version if you'd like to listen to it again or pass it on to anyone else. And then also onto the fun stuff, We are going to be drawing 5 winners from our attendees today to get a D-Link 8-port PoE switch. So our first winner is Liam M. from New York. Our second winner is Bryce H. from Southern California. Also, our third winner, Alan S. from Minnesota. Our fourth winner, Anna A. from Florida. And then our last winner for today is Tom S. from Texas. And so we will have someone reach out to each of you and figure out how to get that PoE switch to you. And with that, we'll wrap it up and again say thank you for attending and thanks, Steve, for all the great information. We really appreciate it and hope to see you all on another webinar. Thank you.
Yes, thank you.